Look, I'm getting, there you go. Sure, it must be yours. I don't think it's mine. Yeah.
Could be a task. Everyone, and welcome to our Knowledge Connections for today, Wednesday, May 11th. I'm very pleased to introduce Neil Hardie, who is a Senior Product Specialist from Kinova Robotics, based in Quebec, just outside Montreal. And I was just telling Neil we've actually had a visit from Kinova a few years ago, so it's great to see them back. Really interested to see what the latest technology is in terms of robotics. I know Neil has been doing a bit of a circuit to some of the other hospitals. So really interested in the potential collaboration opportunities. I know Kinova does a lot of industry partner research.
Yes, we do.
With academia and hospitals. So welcome, Neil. And it's good that we have a small turnout because it means that everybody will get a chance to try to go along.
Yeah, good. Thank you, Tom. Well, welcome. First of all, I'd like, before I get started, just like to know how many of you have seen JACO before or have some idea or familiarity with it. Tom? Nobody else? Yes. Where did you see it?
Yeah.
Yeah, okay. Yeah. All right, so I'll gear my presentation accordingly. As Tom said, I'm Neil Hardie, Senior Product Specialist. I've been 3 years with Kinova now. And I work out of Toronto. The company is based in Montreal. But let me get started here, and we will. Now, I'm just, okay. Of course, we have a, just a minute. Of course, you have a glitch to start with, right? There we go. We like to call JACO a transformational technology for those that that need it and for those that have a use for it. We are Kinova Robotics, and the company is based in Bloorview now, which is just north of Montreal. I think, Tom, at the time you would have heard from Francois that he was here, we were downtown Montreal. This is our own building now, and I can say it's going to change because they're putting a third story on it as we speak. So, founded in 2006, and we hit the market around 2009 with the first JACOs to be sold. We have currently 50 employees. When I started, there were 15 3 years ago. By the end of the year, Charles is predicting we'll have close to 100 employees. So we are growing, and we are a privately held, wholly Canadian company. So, Canadian, it is a Canadian product, Canadian conceived, designed, and built. There's another product like that, and it is also a robotic arm, but we kind of think we have the more practical one. So, now we have been winning some awards around the world and some recognition. Robotics Business Review has named us in their top 50 robotics companies in the world for 2014 and 15. The Manning Innovations Award we received last year, and just this week we received the Governor General's Award for innovation. And that was broadcast, I believe it was on CTV here. I know it was on CTV in Montreal yesterday or the day before. So that's right up to date. Charles Daguerre was our founder, the inventor basically. He was a young engineer inspired by 3 uncles who had muscular dystrophy. One of them, Jacques Forêt, devised his own sort of makeshift arm that he called the Manipulo, went on the side of his wheelchair. Charles sort of took that concept, elaborated on it, and basically Kinova was born, as I said, in 2006. There is Jacques Forêt, and as you might have guessed, the name JACO comes from Jacques. So when I say Canadian conceived, designed, and built, this is where it started. It did not start as an industrial robot. This genesis was as an assisted device right from the start. So, what is it? Well, it's an assistive robotic arm that basically goes on the side of a power wheelchair. As you see, my friend Seb here is using it on his chair, and he uses it daily. It integrates into the chair controls. So basically, we can integrate into any chair, any wheelchair, and it runs through the wheelchair control system. I'll say a little bit more about that as we go along. It is intuitive and user-friendly. The younger you are, the faster you pick it up. Again, I got a little video at the end to show something about that. And it does significantly improve the lives of those with upper body limitations. We see it almost every day in the people that use it. We get testimonial videos, we get testimonial letters, so we do know the impact that it has. Who do we work with? Well, as I said, the major wheelchair companies and the major wheelchair control suppliers, electronics, so Permobil, Invacare, Sunrise Pride, Autobach in Europe, and all of the major controllers like Arnett, P&G, Quantum, Curtis, HMC. So we can work with any power wheelchair virtually. Other partners, and I think Tom, you alluded to this, we have worked with NASA. There's a couple of these that we have a couple at the Jet Propulsion Laboratory that they're using for research. We have worked with iRobot. Google has several. Toyota has a couple. And most of this is around research. And we work with many universities around the world too that use JACO in their labs and research. For instance, University of Pittsburgh just came up with a new control system for JACO that runs on an Android phone. And they did that in their labs, and they used 2 JACOs to do that. They're also working on a voice-activated system there. We're quite a ways away from market with that, but just to let you know that that kind of research is going on. Okay, so basically JACO has 16 movements, 2 basic functions. I'm going to show you that a little later, but just to get an idea of it now. And you know, some of the questions people ask in terms of specifications. In robotics terms, it has 6 degrees of freedom. It's very light, it weighs about 12 pounds. Payload of 1.5, actually it's more like 1.6, but that's halfway back. At full extension, it's 1.3 kilograms. So that means a person could go into their fridge and pick up, say, a liter of milk and pull it out, and it wouldn't exceed the limits of the arm. The control is relatively intuitive. Integration is normally simple, sometimes more complex, depending on the person and the way they run their wheelchair or the way they need. If they have a head array or a sip and puff, it might be a little more complex to set the arm up. And basically, we do it for each individual when we install it. So the hand can now, the new one, we used to only have 3 fingers. Now you can get a hand with just 2 fingers. For some people that's better because of line of sight. This 3-finger hand is a little thicker, and sometimes it gets in the way of seeing what you're actually picking up. So extends out to 90 centimeters, uses the wheelchair controls, as I said, and of course it runs off the wheelchair power system, but it's very efficient. So we very, very seldom get any complaints about people exhausting the power in their chair because they've been using the JACO. Carbon fiber, so this is not plastic, this is carbon fiber. And I hesitate to say you could take a baseball bat to it, but it's pretty tough. So, as I said, we can run it through a number of control options. The first one, of course, would be the wheelchair control system. You see an Arnett joystick there and an Omni display, a head array, chin control here, sip and puff, and of course our own joystick that I have here today. So there are a number of options for different people with different diagnoses as to how they might operate the arm. How does it work? Well, We have our own proprietary software called JACO Soft. And, you know, frankly, most of the technology is in the software. The hardware is sophisticated and very high quality, but the real difference is in the software, and it's really what makes it run. So we have JACO Soft, which is our own proprietary software. I'll just run through a couple of screens here. Basically, you can customize the resting position. You can make it left hand or right hand. You can set another custom retract position other than those indents there. Also, we can set up what we call a drinking mode, and we can, there's mapping information, so we can map the buttons and the joystick and whatever, the head array, the switches, whatever, to the person's needs. We have, and you'll see it at the end in a short video, we can set up a protection zone around the person, particularly when we do a demonstration and we might leave it with them for a couple of days. We want to make sure that they can't hurt themselves. So we build a protection zone around their head and torso, so the arm will come up here and it'll stop. It won't go any further. But gradually over time, people that own the arms get rid of the protection zone, and because it's a bit of a compromise, to be quite honest. If you want to have a drink, you know, if the arm stops here and you're having to reach for it, and again, you'll see that in a video at the end. And then we have a whole diagnostic section and JACO Health Center that you can see what the arm is doing and analyze any problems you might have. And we have something called the Kinova display, which tells you what mode the arm is in. So if it's in translation mode, so forward, back, left, right, whether it's up and down, whether it's the arm, or whether it's the wrist movement, whether it's the fingers, it'll be displayed on here, and we put that in front of somebody so they can see it as they're going through the modes. So basically, who is JACO for? Well, those living with muscular dystrophy, spinal muscular atrophy, ALS, cerebral palsy, and of course spinal cord injury. These would be the majority of our users. Percentage-wise, I'm honestly not sure. I would say spinal cord injury is a major one, muscular dystrophy, and cerebral palsy as well. And we do have quite a few clients with SMA, so it covers the range. What benefits? Personal benefits. This, by the way, is a young man in Australia with his dog. So he actually feeds his dog with the arm now. And he's had his arm, I guess, for about a year and a bit now. So more freedom and independence. Obviously a more productive and active life because you can get out and do things. Improved confidence around your ability to do daily tasks and to interact with the world. Improved family relations. What it means is it takes a bit of stress off the family as caregivers. They can leave the home with a little more confidence that the person left behind will be able to function. And as I said, reduce family stress. The next one, this is my favorite picture. This is, by the way, is a man in Holland, and as you see, the arm's a bit banged up. He'd had it for a while when we took this, it just shows you it's just a few chips off the paint and whatever, but I think that's great. So it saves on attendant care. It can reduce the cost on the burden on the healthcare system because of that. It sometimes enables family members to go out and seek part-time employment, and of course, even the users can go out and seek part-time employment or employment in some ways. Basically, our poster boy, Seb Lepage, who was in a previous slide, and you'll see at the front of our brochures, works for us. He worked for us right after he got his JACO. Then he went off and worked for his family's business, and for some reasons, whatever family conflict, he came back. So he's working with us again. But he works every day, and he uses his JACO basically like his own arm. So, And it does increase the productivity of the users and their families, as I said. So just run through some pictures here. What does this look like in the real world? What are people doing with it in the real world? Well, obviously you can have a drink. A couple of these, by the way. By the way, the reason we have quite a number of, I have quite a number of pictures here of people from Holland. And the reason is that the Dutch government funds this. Their health insurance funds JACO. So we have well over 100 JACOs in Holland. And the first ones were there that we had users for, and they're now about 5 years out. So we're beginning to see what happens after that length of time. So a lot of these pictures were in Europe, taken in Europe. This is what you see in the arm there in the hand is what we call an eating block, and it enables you to put a fork or a spoon into the block, and then the arm can pick it up, and you can manipulate the fork with that. And here's another image of that. And this is interesting. These two, this gentleman on the left is Bob White. He was our first American user. And this one is Seb again, and this is Seb feeding his new nephew. So, and you can feed your fish. You can water your plants. This gentleman again, a Dutch user, was a photographer before he had an accident, and he's still doing photography now with his JACO. And yes, you could do makeup. Two young gentlemen from Holland, as you see, Sip and Puff here on the bottom one. This young man again, well, it looks like he's watering some plants there. And just run through these quickly. This was at the OT conference in Banff, OT Bear. So OT Bear is getting a drink from JACO.
Attention please, attention
So,
please. The fire panel is currently offline. If you take smoke or fire, please call 5555 and state location. Thank you.
I'm going to run,
Attention please, attention please.
I'll wait.
The fire panel is currently offline. If you take smoke or fire, please call 5555 and state location. Thank you.
I'm going to run a quick video here. I had a couple to choose from. This is our own video, and the reason I'm running it is because there are a bunch of kids in here. And I thought you guys might like to see more video of that. So let me just run that. I'm not sure what the sound will be here, Greg, on this, but we can. That a bit louder, okay? Okay. Now this one. This is about 30 seconds long. And yes, I have permission to show it. This is a 9-year-old boy in Michigan, Micah. And I had done a demonstration for him and left it with the family overnight. And because of that, I had put a protection zone around Micah. So Micah's going to take a drink, but you'll see that he's stretching a bit to get to the drink, to get to the bottle here. So that's the reason he's doing that. I had just come in and we hadn't taken the protection zone away, so it was still there. And he wanted to talk about this, so I did a quick little interview with him. And anyway, you'll see he's quite keen. But just let me run it. It's pretty much self-explanatory. So. Okay, Micah. So tell me, how did it go with JACO?
Good, really good, and I accomplished many things. Right now I'm trying to get myself a drink.
Now, were you able to get yourself a drink before JACO?
No.
No. What else did you do with it last night?
Fed myself and help them out cook.
Wow. Wow. So do you think, I'll wait till you have your drink. Cool. So do you think JACO would make a difference for you in your life?
Oh yeah, I can do way more things than I could before without it.
Oh, that's super.
Yeah, it's just makes life a lot easier to do things too.
Good. What do you think, Isaac? Yeah? You like that? Okay. Okay, Micah, give me a smile, say goodbye.
Bye.
Okay, we'll see if we can get JACO back for you, okay?
Okay.
Okay, thanks a lot. Bye-bye.
You got this.
We did get JACO back for him. This was a family with, well, very low-income family, just north of Detroit. And we were able to find a donor in Texas that actually just bought the arm. We sent this video down, and 2 days later, he bought the arm. And a month after this, Micah had his JACO. So we were able to do that. And I can tell you what I said earlier about, you know, the process of how intuitive it is and learning. I'm obviously an older guy. It would take me a couple of weeks to learn what it took Micah about 5 minutes. Micah was picking up a drink before I actually had finished tie wrapping the wires to his chair. And I hadn't actually done a demo for him yet, but he was beginning to figure it out before I even showed him. So a very bright 9-year-old. He's now 10, of course, but there you go. Okay, so I'm going to take some questions. And actually, before I do that, I just want to run very quickly to another product, but we also bring in from Holland, because we have a Dutch distributor and they manufacture things. We have some arm supports. I chose the one on the left is called Going. And if you're interested a little later at the end, I can maybe show you a quick video on that. I have a brochure here. But I wanted to focus on JACO today. We do have a Going here in Toronto. We only have 2 in North America right now. So I would be happy to show it to anyone at some point, but we're just making you aware of that. So let's go back to here. Questions? Yes?
How is it connected to the wheelchair? Is it directly to the controls or like an ECU?
Yeah, it can go through an ECU. For instance, with the RNet system, we now have we got a card from Penny and Giles that goes into our control box, which translates the signal normally from the ECU. But with the card, we can eliminate the ECU, and it becomes a direct connection.
So how do they switch between driving the wheelchair and using
They do it on the profile of the chair. So would you just go to mode on the chair, and you would see, so then you would see the drive modes, whether it's 1 or 2, and then you would see, you know, this tilt modes or whatever, and then there would be another one. And if we set it up, when we set it up in the software, we name it, so it says JACO. So They go there. What we don't do, and what we haven't done yet, is allow the person to drive their chair at the same time they're operating the arm. That to us is a little bit like texting and driving. But it's going to come because, as I said, University of Pittsburgh, for instance, has now an Android app that will run this. So now you could be running your chair and you could be operating this. You know, so it's, we're not quite sure where that's going. None of it has been certified, none of it's been tested in the real world, and the biggest concern we have is always safety. So, you know, we want to make absolutely certain that our engineers certify it before we put anything out. So these are probably even pre-beta versions, if you will. So, yeah. Any other questions? Yes?
Why use carbon fiber instead of plastic?
The question is, why use carbon fiber instead of plastic? It's a much tougher material. And again, we want the arm to be as robust as possible. It's very light. And it does add to the cost, yeah. But we do know that, you know, people could go through a door and bang the door frame or whatever. So we have very, very few. In fact, I'm not familiar with an arm that has been cracked or broken that way. And I'm sure if it were plastic, that would have happened. Yeah. Anybody else? Yes.
You mentioned about 100 units in Holland.
Yes.
And I was just wondering if the Canadian government has any kind of funding support for this kind of.
So the question is, does the Canadian government have any kind of funding support for this? Simple answer is no at this point. We have been in touch with the ministries of health. Here I can say the ADP does not fund this. We're probably a little closer in Quebec than here. Maybe the closest we're going to get, and I'm not sure yet, is Veterans Affairs. We might have some traction there. But we have a new government, so, you know, we can be hopeful. But so far, no, there is no government funding in Canada.
How many devices are in Ontario?
We now have, I got to get this right for Ontario because it's just changed. I believe I have 7 in Ontario now and about 30 in Quebec. I have none out west at this point. Part of the issue there is that we need a good dealer, distributor to support it, because you don't just come and give somebody one of these. You have to demo it, you have to put it on the chair, it has to be customized to the person's controls, to their diagnosis, and you know, all of that has to be done properly, of course. And so it takes a little bit of training for somebody to do that. And so far in Canada, we've been doing it ourselves. In the rest of in Europe, we have distributors. We have a very good distributor in Germany and an excellent distributor in Holland, and they have the technical expertise to do all of that. But so far in Canada, because we're here, we've done it ourselves. So, yes?
What's the minimum number of like switch inputs to use it? Like a joystick might have maybe 4.
Yes.
But you show that you can use like a single cloth or like a headset.
Yeah.
But those have maybe like 2 or 3.
Well, you can do I would say 4. On a sip and puff, you can do, you know, a hard puff, a hard sip, you know, soft puff, a soft sip, that sort of thing. So you can get 4. We have actually one of the users, the only user here in Toronto actually, uses sip and puff, and he does very well with it. So yeah, basically 4 would be the minimum. But you can map it in any number of ways. So even a joystick could even be used in 3 directions, and then we could have a switch for something else, or we could have a double, you know, shift of the joystick, whatever. So the software is pretty open to mapping those inputs. So, and I'm not an engineer, so, but our engineers would have a much better explanation than that, I'm sure. But yes?
I'm almost afraid to ask because it looks like it's such a great tool, what the cost for the end user might be.
So the critical question in the room is, what is the cost? In Canada, it's $35,000 retail. In the rest of the world, it's $35,000 US. But in Canada, we keep it in Canadian funds. So, and yes, of course, that means for many, many people that might need it, it's a burden, it's a problem. But people have done fundraising. We also have a foundation in Quebec that has funded some. We have people that get creative about it. And of course, you occasionally have people with spinal cord injury settlement, for instance, are able to purchase one. Two that we sold in Ontario, one was actually down near Windsor, was a retired robotics engineer. He used to work on the car assembly lines on robots, and then he acquired one of these, and he actually talks to our engineers quite a bit, and he's playing with our API. And so, and then the user in London is a spinal cord injury settlement, so he had some funds and was able to purchase one outright. So you find those. But obviously, we do not do the volume that we can do in Europe because of their health scheme. Yes?
Can it be customized for a person who uses a head switch to operate a power wheelchair? So instead of the joystick, it could be on the head switch?
Yes, so the question is, can it be customized to be used with head switches for a head array? And yes, it can be. Yes, we can do that. In fact, I think you saw in the video somebody even using their feet with it. But there was, yes, we can do a head array. We've actually done 2 of these for the war amps for people with no arms at all, and they just used their feet. So in one case, the gentleman used 5 switches and no joystick, and in the other case, a young woman out in Calgary used this joystick. So, anything else? Yes?
Any empirical evidence around the effectiveness of
We have a number of clinical studies. The question is, do we have any empirical evidence around the effectiveness of the robot? Yeah, we have a number of clinical studies. We are trying to get better at that. We've just hired our own occupational therapist, and she's going to be doing some data collection from our users. We've had, for instance, in the States now, we've had 2 private insurance settlements through one Blue Cross and one Blue Cross subsidiary. And they used a clinical study from 2012 that we kind of thought was maybe out of date. But they used it and said, yes, this is real. And they had a letter of medical necessity from the doctor, and they funded it. So, yes, there are studies out there, but hopefully we're going to be getting some better ones. And I'd be happy to send you some if you were interested. Yes?
Just related to that, is there a work going on in Holland since there's such a high rate of use in Holland?
Yeah, actually one of the better studies we had came out of Holland. And I forget the number of users now, but I think it was something like 36 or 34 users that we used in that study. And again, I'd be happy to send that along. And basically, yes, it did. I mean, we had like an 80% approval rate from those people, and it did show the kinds of things we're saying, that people are able to do more, they have more confidence, they feel more independent, you know, and their lives are improved significantly. So, yes.
Would you be able to use a touchscreen with the fingers?
Ah.
Anyone use it?
The question is about a touch screen, whether we could use a touch screen with the fingers. If we have some time, I might be able to show you. We do have a computer display where I can use a mouse to control the arm on the screen. The touch screen, yes, was done on the Android at the University of Pittsburgh. It's actually a circle, and you just move your finger around, and the arm moves.
But I'm asking more like access a phone with the arm. So like for someone that can't use a touchscreen like an iPhone or anything like that, to actually touch the screen and access the
Oh, with the fingers, you mean? No, at this point, they wouldn't. They would not do that. I mean, I suppose we could put something on the end, but at this point, no.
Can it hold the stylus?
Yes, could hold a stylus. What people find, though, is if you see in the video, what Seb does is he has a patch of Velcro on the wrist, and he brings his phone up and he uses his nose. So, yes.
I just noticed that when you were talking about the diagnostic report using R, you didn't mention anybody with severe head injuries. Would that be
With what, I'm sorry?
Severe head injuries.
So the question is about people with severe head injuries. That would be interesting. I'm not sure, because if the severe head injury translated to some sort of a cognitive disability, I would say no, because this does take, you know, there is a learning curve, and
But then this is being used for patients with cerebral palsy, which
Yes.
some of them, so you're talking about some cerebral palsy clients who have for higher cognitively functioning?
Yes, we have, for instance, Seb has cerebral palsy, and he's a pretty bright guy, you know. We found, for some reason, or maybe you guys see this too, people with SMA tend to be quite bright people, at least in our experience. That's what I found. Like little Micah there, and our user down in southwestern Ontario have a spinal muscular atrophy, and they're very bright. So I don't know whether that's a real thing or not, but it's what we've experienced. So yes.
On the same line, do you have clients with severe head injuries with some challenges cognitively because they were driving a power wheelchair?
To be quite honest, I don't have an answer for that question. The
That's
question,
something we should investigate.
it could.
Some of them has insurance, private insurance money, that I can see this improving their quality of life so much.
Yes. So the question is around people with severe head injuries and whether we might, and having some cognitive ability, whether we might be able to help them out, and whether I know of any, and I do not know of any at this point. We have seen cases, we have seen at least one case. There was a woman in Germany, for instance, who we put an EMG sensor behind her ear, and they taught her to move these muscles back here. And she actually can control the arm, and she basically can't move much else. She can move her legs, so the mode switches, I believe, are on her knees, so she can click her knees together and change the modes, and she can operate the arm by moving her ear muscles. So I mean, they're all kinds of, yes. I mean, we're looking at more and more of this as we go along. So the future is really in the control. You know, whether we ever get the brain-computer interface or not is an out there question. But in between, there's a whole bunch of things that we could do, I'm sure. So yes, if you're interested, we'd be interested in talking to you about that.
We use with our clinician on brain injury, that there's specific lights in my head that I think would be perfect.
Yeah, we'd love to look at that. I mean, we're happy to do a demo too, to come and you know, try and, you know,
Yeah.
put the arm on a chair and.
Vision ones, even though they're changing all the stuff they do.
We have some access to
Yeah.
some money. This is really great for independence.
Yes, absolutely, absolutely. Independence, confidence, safety. You know, yeah. I should actually show you guys this arm. I mean, so far we've just been talking, so it might be. It might be good to actually turn it on and use it, if I may. Any other questions while I'm... So, first of all, as I said earlier, I'm using in a way I'm cheating. I do not have a power chair here. So if I had, we would be running it through the power chair controller. This is our own joystick, so it works a little differently, but again, it just shows you that there's a range of control that you can use. So first I put it in its home position, and now it's able to function. So basically I can go forward and back and left and right, and in this case I can twist to go up and down, and I can also change it on here, so I go into what we call two-axis mode, so up and down would be forward and back on the joystick. But for the moment, this is what I'm doing. So you can move it around, left, right, up, down, as I said, and of course now we can get it. You can get it to go vertical if you want, in wrist mode, and I can twist it side to side like this, and of course we can open and close the fingers. And I can open and close just 2 fingers, or I can do all 3 fingers. So suppose, just suppose, and I think this might have made Lise a little nervous earlier, but I assure you that we won't spill this water. JACO and I. JACO assured me he wouldn't spill this water. Now, there are no sensors in the fingers. That's a question we get. It's basically intuitive, and if you come up later, I'll show you that the force on the fingers can't hurt a human hand. So it's designed, it's a bit of a compromise, but it's designed to pick something up without crushing it. If I wanted to pick that bottle up with just a little less force, I could do it, but I'm going maximum on that right now. So what do you think, Lise? I think I got to come back a bit. There we go. So this took Micah about 2 minutes to learn. Took me a week. So of course then I could pick the glass up. And if I were in a wheelchair, this is much more effective if you see it in a wheelchair. Again, with the fingers, as you see, I can sort of vary the force on that. So, if I wanted to have a drink now, so I can do that. Actually, I should come up a bit. So. Yes, I really did have a drink. So that's just a basic demonstration of one of the things you can do with it. Any number, I mean, our users are continually coming up with different things. We have a young woman, Laura Barrett, in Colorado. Certainly within the first couple of days she had it, she went out to her outside mailbox with the key, put the key in, and opened the door for the first time ever. So now she does that on a regular basis. Things like elevator buttons. People couldn't push them, but you can do presets with this so that you could do a preset position. You go up to your elevator, stop your wheelchair in the same place, press your preset, and it'll push the down button. Things like that people can set up. Yes, Lise?
Okay, so if you can push an elevator button, why can't it push a touch screen? Because there's no sensor in the fingertip. There has to be a temperature, like a temperature sensor for it to work. Like if you, yeah, it's not that it couldn't actually go to that position. It's just when it got there, it wouldn't have an effect, unless I don't know, unless it was a fluke of some kind. But yeah, and that's a question we've had too. For instance, for tablets, whether you could do that or not. But yeah. So. Any other questions now you see? Yes?
So does it come with other parts for the fingers? I'm looking at the fingers, they are quite flat. So can the user be able to customize the fingers as well?
So the question is, could the user customize the fingers, or does it come with other parts of the fingers? We're working on tools like the eating tool you saw in the pictures. For the assistive version, the only two things we can do are 3 fingers and 2 fingers. In the research versions, which look virtually the same as this, except that often researchers don't even buy the gripper. They put something else on here. So whether it be for medical research, maybe a surgical tool of some kind, at JPL, they could be doing other things with it. It's really up to the researchers, and they would program that into their software. But in terms of what you might attach to here, I've often thought we should have maybe a little attachment for why can't I think of it? Chinese food. Chopsticks, sorry. Yeah, my brain. Yeah, for chopsticks, for instance. And if you just use 2 fingers, you could probably do something with that. So, like if I just had these 2 fingers, you know, but yeah, we don't make anything to go on there at this point. Maybe down the road, and we're always looking at possibilities for those things, but at this point, no. So, yes.
Another similar tough question about cost. Like, very impressive. It looks very high quality. Is there in Kinova the thought to make a low cost
Yes.
version that might have some?
So the question is, were we considering a lower cost version? And the answer is very much yes. There is actually a smaller one of these. We call a MICO, so for a mini JACO. And frankly, we sell more MICOs for research than we do these. The reason this is the size it is because for assistive, for somebody in a wheelchair, they have to be able to reach to either into the fridge or the counter or the table and to be able to pick something up off the floor. This is designed to pick something up off the floor. The smaller one won't do that. It's a little cheaper than this, but we're actually looking down the road at a version that's, you know, significantly cheaper. It will be limiting. It won't have the functions, but it hopefully will be quite useful. And I don't know how far away we are with that. I wouldn't want to say, but we've started looking at it. Yeah. And does anybody want to come up and play? I mean, actually use it?
I'll turn the camera off.
There you go, Greg. Any other questions or? Yeah, this is always a question. Who's going to go first, right?
Just before we play, I want to thank Neil for presenting
thank you.
today.
Thank you, Derek.
It's just a small gift that we.
Oh, wow. Thank you very much.
I want to try this at first.
Yeah.
Go.
Here. I'm going to put do you mind if I put the top on the bottle?
Yes.